Alright, so in this video, we're going to be solving the equation x to the power of x is equal to 8. So, at first glance, this problem may look challenging. So, to solve this, I'm going to first start by taking the ln, or natural log, on both sides. So I'll get ln x to the power of x is equal to ln 8. And a helpful property that comes with logarithms is that if I have something in the form ln a to the power of b, I can move this exponent to the front, so this turns into b times ln a. So in this case, I have ln x to the power of x, and I can move x to the front. So now I get x times ln x is equal to ln 8. Now from here, I'm going to use another formula that states that if I have something in the form w of a times e to the power of a, this is equal to a. And this is something known as the W-Lambert formula. So if I take the w of something in the form a times e to the power of a, it's going to equal a. So in this case, I'm going to rewrite this as ln x times e to the power of ln x is equal to ln 8, because x is the same thing as e to the power of ln x. So now I can use this formula. So I'm going to take the w on both sides. So I have w of ln x times e to the power of ln x is equal to, what I have to do on one side, I have to do the other side. So I w of ln 8. And this simply turns into e to the power of ln x is equal to, ln x is equal to w of ln 8. And then now I'm going to take e to the power of both sides. So I get e to the power of ln x is equal to e to the power of w of ln 8. And e and ln cancel out. So I get x is equal to e to the power of w of ln 8. So this is my value of x. If you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends and family members. And I have a lot of problems like these on my channel, so please make sure to go ahead and check them out. Thank you guys for watching. Alright, so in this video, I'm going to solve the equation 1 to the power of x is equal to 2. So, before we even start solving this, if, let's say, x is equal to 1, then I have 1 to the power of 1, which is equal to 1. And if x is equal to 2, then I have 1 to the power of 2, which is also equal to 1. And you can go even 1 to the power of 10 is still equal to 1. So you may be thinking, what possible value of x can make 1 to the power of x equal to 2? So let's try solving this. What I'm first going to do is start by taking ln of both sides. So I get ln of 1 to the power of x is equal to ln of 2. And ln is the same thing as the natural log. And the reason I took the ln on both sides is because it comes with a property that states that if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this turns into b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front. So I get x times ln 1 is equal to ln 2. And you may be thinking, we could just divide both sides by ln 1, and x would equal ln 2 over ln 1. However, the only problem with this is that ln 1 is equal to 0. And remember, anything divided by 0 is undefined, so this would be undefined. So we know that this equation has no real solution, but it could still have imaginary solutions. So to actually solve this, I'm going to use something known as Euler's formula. And basically what this formula is if I have something in the form e to the power of I times theta, this is equal to cosine of theta plus I times sine of theta. And I know to many of you watching this video, this may just sound like a bunch of gibberish, but just hang on. So let's say that theta is equal to 0, right? Say that theta equals 0. So now I get e to the power of I times 0 is equal to cosine of 0 plus I times sine of 0. Cosine of 0 is 1 and sine of 0 is 0. So I get this all is equal to 1. Now, what if we say theta is equal to 2k pi? And k is just a substitution for all real numbers. So now I get e to the power of I times 2k pi is equal to 1. Because all we did was we just substituted theta in for 2k pi into this same thing. So now, because this is equal to 1, we can remember our first equation, which we started with 1 to the power of x equals 2, we can substitute in this for 1, meaning I get e to the power of I times 2k pi to the power of x is equal to 2. So just think of this as 1. So I have basically 1 to the power of x equals 2. And now with this, I'm going to take the ln or natural log on both sides. So I have ln e to the power of I times 2k pi to the power of x is equal to 2. So I'm going to now bring this x down using property of natural logarithms. So I get x times ln e to the power of I times 2k pi is equal to 2. Is equal to ln of 2, because if you take ln on one side, you have to do the other side. And now I can also move I times 2k pi to the front. So I have I times 2k pi times x times ln e is equal to ln 2. ln e is simply equal to 1. So I get x is equal to ln 2 over I times 2k pi. And now I'm going to multiply this by I over I. So I get x is equal to negative I times ln 2 over 2k pi, because I squared is negative 1. So this is my solution.